Right, welcome to the second part of these videos. In the first part of the video, we've got the laboratory power supply that supplies a direct current to this feedback oscillator. The feedback oscillator is generating an alternating current in our transmitting antenna over here. Our transmitting antenna, our receiving antenna, 50 turns of enameled copper wire, and the induced current can be seen on our light emitting diode over here. Right, so that's a recap on where we've been before. So what I'm going to show you now is the orientation of antennas. You can see that this antenna, the transmitting antenna, the electrical part, which is the wiring, is oriented in the horizontal. It's lying flat, in other words. Similarly to our receiving antenna is in the same orientation. We call that the polarization of the antenna. Now, watch quite clearly what happens when I move the receiving antenna into a vertical orientation. Watch clearly on the oscilloscope. What I'll do is I'm going to switch off you'll see that nothing happens to the alternating current that's being generated in the transmitting antenna. So I'm going to switch that off. So now you can see only the current that's being induced in our receiving antenna. Now watch clearly, and I'm going to turn it such that you can actually see the LED. You can see the LED, there's no light being emitted by the light emitting diode, which indicates that there's no current being induced. And you can also see on the oscilloscope, there's virtually no current being induced in our receiving antenna. So very important. The orientation of the receiving antenna needs to be in the same orientation or polarization, as we call it, as the transmitting antenna. Watch clearly now what happens when I drop it back. You can see how the LED starts lighting up. You can see how the current induced, as shown by the oscilloscope, increases. So, thank you for watching. So, let's just recap. This means that very important as far as your outside antenna is concerned is that the orientation as far as vertical and horizontal needs to be correct. Otherwise, you're not going to get the optimum signal induced. Now, something to talk about is we have a way of orienting our antennas at different angles, and that is because of something that's known as magnetic reflection or electromagnetic reflection, really, as far as the electromagnetic wave is concerned. And I'm going to demonstrate that next. Thank you for watching. Be sure to watch the next one on electromagnetic reflection.